Continuing with our final exam review, we've got a few vector problems. We didn't spend very much time on vectors, so the only problems that would be on your final exam would be similar to these. So if you practice these problems, you're in good shape. So we've got a couple different ways that we can add and subtract vectors. We could draw them visually, or we could write them in vector notation. So remember that vector A we could turn into its I and j components. So it looks like it would be a -8 in the I direction. Our unit x vector, we're going 8 in the I direction, and then we're going up. Again, it looks like 8 in the vertical direction, so there's our I and j notation. And vector B is 4 in the positive x direction and 4 in the positive j direction. So this is a very easy way to add them together. So we would add the two vectors to get our new vector. We'd simply add the like terms, and we get -4i hat positive 12j hat. And remember, the visual idea would be to simply say, well, we could do where we left off on one vector, put in the other vector. And whichever way that you did that, you would end up at this spot right here. So our vector, we could do our resultant. Remember, the answer is called the resultant. And there's another way to see, does it look in fact like we went 4 units and 12 units? So you could make your parallelogram to find the resultant. So let me write that word here so you remember that. When you put the two vectors together, we get the resultant. Okay, to find a minus b, we would just put b going in the opposite direction. So we could visually draw it, but just turn the arrow around on vector b. But we already have the two written right here, so if I want to do a minus b, remember that if we subtracted -8i minus 4i, so now I'm just using my columns up here and subtracting them, and we have 8j minus 4j. So we're just subtracting the like terms, the same as we would with any other type of problem, add or subtract like terms. The opposite of a, simply take our previous notation and do the opposite. So we would go in the positive I direction and the negative j direction. So arithmetic with vectors is just like arithmetic in all of algebra. All right, so in your textbook they use boldface for the vectors. They don't always draw the vector symbols. They don't put the little hats on the I and j, but we know that that's what they mean. So here we're given the notation, so we're just doing what we did last time without visually seeing the vectors. So it's simple arithmetic. 2 times a, we simply double each component. So just double their coefficients, and out of habit here, if we put the hats on the unit vectors I and j, you could put the arrow over the name of any vector. Your textbook just happens to omit that. Okay, then we want to do this next problem, 2a plus 3b. So as long as I already did 2a, that was our answer for the first part, let me do 3b right below it. Same idea, I just want to triple. So I just want to take what vector b was and triple each of its components. And now we can say, well, what is 2a plus 3b? The resultant vector is exactly what you think it should be. So we add these together, we get positive 1i and positive 1j. So we don't really need to write the ones. And then we want to do a b minus a 3a. So you might say, do I really have to rewrite these? No, you could do this arithmetic in your head. 3 times a is -3i plus 6j. And now we want to subtract those two things. So remember, b minus 3a. We'd have a positive I minus a negative. Subtracting a negative becomes positive. So we would get 4i. And negative 1j minus negative 6j is negative 7j if my arithmetic is correct. So it's just like adding and subtracting like terms. All right. Sketch the resultant for vectors u, w with an angle theta between them. I've got a scroll here. That's the end of that sentence. And remember, when you have these absolute value bars, again, different textbooks might put magnitudes in two absolute values, but the magnitude, when you see that absolute value around the vector, the magnitude is the length. So remember that vectors have two components, a length and a direction. So here we want to do one vector with a length of 8, another with a length of 12, and we want the angle between them to be 30. So it doesn't matter what direction we draw them in. So we want one vector of 8, one vector of 12, and the angle between them is 30. And this is our vector u. And let me put that maybe on the inside of my drawing so we don't get that confused. And this is my vector w. And we want the angle between them to be 30. Maybe the 12 should be a little bit longer. But our question here isn't asking us to do any algebra yet. It's just asking us to sketch the resultant. So this is just to have a visual understanding of the vectors. So remember, an easy way to find the resultant, you could take this vector and move it over here. We can complete the parallelogram. So completing the parallelogram shows us the resultant vector. So this vector is the resultant. In the next problem, you're actually going to find the magnitude of that resultant. So if you went ahead and did more than I've just done here, let me show you what we're going to do in the next problem. We know the opposite sides of a parallelogram are congruent. This 30 did not get bisected, so I can't say we've got 15s here. That would not be true, but I do know that consecutive angles of a parallelogram are supplementary, so I do know this angle is 150. So now I've got a side angle side problem that I could use law of cosines to find the resultant. So let me just set that up here. If I call this resultant, I don't think we had a name for it up there. I'm going to call it C. So remember what law of cosines looks like. It is the two sides squared minus 2 times those values times the cosine of the angle between them. And the cosine of the angle between them is not our angle 30. It's the supplement of our given angle 30. All right. So since you won't have a graphing calculator or a trig calculator, I might ask you on the final exam to set up this statement, but then I would not ask you to calculate it. Okay, that's actually more than this problem asked for. Remember, all this problem wanted you to do is to remember that a parallelogram can be used to sketch the resultant vector. All right, so now we should have some repetition here. In a couple more, find the magnitude, that's the length, and the direction angle. So this vector that we're working with is given right here. I've got a problem with my screen. This diagram should be down a little bit lower for the next problem, so pretend that diagram isn't visible to you yet. So we want to take this, remember this is called position notation. Position notation means that the angle begins at the origin. So we want to travel -7 units in the I direction and then 24 units in the J direction. And there is our vector. Let me make these both dotted. So we're traveling -7, then we're traveling +24, and there's our resultant vector. And the magnitude of that vector, so we're asked to call that vector u. The magnitude of u we write with absolute value signs, And do you remember Pythagorean triples 7, 24, 25? If you didn't, then you'd have to go through Pythagorean theorem. And now we want the direction angle, so we need to find this angle right here from standard form. Well, the first thing that we need to do is to find this angle right here. And again, don't worry about this too much on your exam because you're not going to have a trig calculator, so I'm going to put x there. Do you see that we could write tangent of x because tangent is opposite leg over adjacent leg? So on your calculator, you would do inverse tangent of negative 24 divided by 7, and your calculator would give you the value for x, and I'm going to pause and find that. On your exam, I don't think I can ask this question because you won't have a trig calculator. And my calculator tells me, and I'm going to round this off, that this is about negative 74 degrees. Now, obviously that angle is talking about this reference angle down here. So think what we want. Instead of negative 74, we want to change that to its supplement. So let's see what we come up with here. So instead of this negative 74 degree angle, which is equal to that purple angle, our green angle, I wanted to switch to green there, and I'm having no luck. So the green angle in our picture, theta, is 106 degrees, the supplement of that 74 degree angle. Okay, so as long as you recognize that tangent is vertical leg over adjacent leg, you will be good to go. Then you would grab your calculator. All right, now let's see. We got to get my diagram. Let me pause and try to fix my diagram. All right, so we're back in business here. We want to write this vector in this form. Remember, this is simply position form, so it's not the numbers 7 and 24. It's telling you that we want to use this XY format. So here we've got a 120 degree angle and a magnitude of 8. So let's think what we know here. This angle next to this must be 60 degrees. So let me enlarge this. Here's what we know. We've got a vector with a magnitude of 8, and it's making a 60 degree angle, and now we'll have a 30, 60, 90 triangle. So our x component, 30, 60, 90, our short leg is half of the hypotenuse, and our j component, our long leg, is half the hypotenuse times the square root of 3. So back in geometry, you called this family the x radical 3 family. So you've been certainly using that in geometry. So now what do we know about the coordinates of this point? We know that we went negative 4 on the x and positive 4 radical 3 on the y. And finally, one type of trig problem that I might ask you to set up, but again, 132 degrees is an angle you would need a calculator to do. But let's understand the problem at least so that we could set up a formula even if we can't calculate the answer. So we've got two forces of 283 and 125. So those will serve as the magnitudes or the lengths of our two vectors, and the angle between them is to be 132. So simply make a diagram. Think about how large a 132 degree angle would be, and notice that the 283 is more than twice as long as the other. So I'm going to let this one be my 283 magnitude vector, and this one be the 125 magnitude vector, and this angle, and again I just roughly estimated an angle of 132. So to find the magnitude of the resultant force, remember the resultant is going to be somewhere between them. Specifically, we simply put these end to end, or you think of it as turning it into a parallelogram, and this point right here determines our resultant. So from our starting point, the diagonal force in that parallelogram. So there's our resultant, and we're looking for the magnitude of that resultant. So let's call it V for vector. You could pick any letter that you wanted to. Remember now from one of our previous problems, this 132 did not get bisected. However, we do know that consecutive angles of a parallelogram are supplementary, so this angle must be 48. Opposite sides of a parallelogram are congruent, so now we can pick either of these triangles. So I'm going to focus, let me show you the triangle I'm going to use. I'm going to use this triangle because I've got a side, angle, side, side, angle, side. So I would set this up using the law of cosines. So to find the magnitude of v, that would be v squared. So if you want to save a step, you could put the square root on the other side right away. And here's our law of cosines. 283 squared plus 125 squared minus 2 times 283 times 125 cosine of 48 degrees. And you would go to your calculator, but setting it up is what we would be interested in.